folks, in a previous couple of pre-works, we reviewed the basic principles of factoring, and we also learned how to factor some trinomials. But the ones that we looked at did not have these large composite numbers for their leading or trailing coefficients. Instead, I kept many of them to be prime to make the problems not too difficult. We're now going to look at some harder ones. There's no actual new content in this section. Instead, the problems are just a little bit more difficult. Okay, so I went ahead and actually did some of the work that you might write out when you're factoring a trinomial. So what I did here first was I took the leading coefficient, which was 35, and you can see that I listed out all of the factored pairs of 35. I also took the trailing coefficient, which was 12. There's our trailing coefficient, and I listed out all the factored pairs of 12. And then remember what we're doing. The first thing we need to do is identify the sign on this second term here. And this sign here, the sign on the trailing coefficient is negative. So we're looking for the terms to subtract to the correct term. Let's give myself, let's see, a new color, subtract. Okay. So you can see that in all of these instances, I'm checking to see whether the terms subtract to give me the correct middle coefficient, where the correct combination of the, when we added together the outer and inner terms. Okay. Then all I really do in this method, or frankly any method for factoring of large trinomials, is I'm just going to look at all possible combinations. And at the end of this pre-work, I'll give you a little bit of a hint as to what's actually going on here and how you can speed this up. For right now, notice what I did. I took this number 1 right here, and then I multiplied it to this number 1 right here. And then I took this number 35, there it is, and I multiplied it to this number 12. And then what am I going to do? So I'm going to multiply 1 times 1 together, and if you do, you get 1 times 1 is 1. Then we'll do 35 times 12, which is 420. And then I'm going to check to see if they subtract to give me the middle term. And so if you actually perform that subtraction, you get in absolute value, you get 319. I'm not going to worry about whether that's positive 319 or minus 319. We'll take care of that sign later. But notice that 319 here, let me put that in a different color, this 319 does not match my middle coefficient. Okay? Let's do it the other way. So now let's go ahead and we'll do 1 times, so we're looking at this 1 times 12. And then we've got this 35 multiplied to this 1 here. Okay? So I'm taking one of these pairs, multiplying it to the other, and then taking what remains and multiplying it to what remains of this pair. And I'm just going through and checking all combinations. Notice that once I checked 1 and 1 and 35 and 12, I still had to check the opposite combination. So what did I do between here and here? I did 1 times not 1, but the 12, and vice versa. So I swapped that, and I again checked to see whether they subtract to give me the middle term. Now, let me give you a little bit of a hint. First of all, you do not need to write this with absolute values. That's just me showing a little more formally what's going on here. So you don't need to write that with absolute values. The next thing is as you're checking this, as soon as you realize that the two terms you're multiplying won't subtract to be minus 1, you don't have to finish the computation. So even though I finished the computation in most of these, you don't actually have to do so. So for instance, when you do, so here we've got this 1 right here, and now we're going to multiply it against this 2. So that's where I did this 1 times 2 right here. And then I took the 35, its factor pair, and multiplied it against 2's factor pair, which is 6. So there's where I did the 35 times 6. 35 times 6 is 210. There's no way that's going to subtract. I'm going to subtract one from the other to get the absolute value of 208. There's no way that's going to work. So you don't even need to do that computation. As soon as you say, I'm going to take 2 and combine it with 35 times 6, will that subtract to give me the number negative 1? As soon as you realize that doesn't work, you don't have to keep checking it. But again, you do have to run through the gauntlet of possibilities. So we just did, previously we did 1 and 2, and then 35 and 6, but now we have to flip that. Now we're going to do 1 and 6 right here, and then we'll do 35 and 2. Well, 35 and 2 is 70, and 1 times 6 is 6, those would subtract in absolute value to give you 64. Specifically, those subtract to give me something other than the term negative 1 there. So here you can see I'm running through all of these possibilities. So let's start filling some of these in ourselves. As I was going through, and you can see none of these have subtracted to give me negative 1 yet. I'm going through. Here we checked all the possible combinations of 1 and 35. 1 and 35, 1 and 35. We did that with all the possible factored pairs of the trailing coefficient. Okay? And so now we need to take the other pairs. We're going to do, we now know this won't work because we checked all possibilities and none of them gave me a negative 1. So now I'm going to do just 5s and 7s. So we'll do 5 times 1 and then 7 times 12 and then the flip-flop. Then we'll do 5 times 12 and 1 times 7. So let's go ahead and do this. We did 5 times 1 and then, so there's 5 and then there's that 1 and then this 7 and this 12, there's that. And when you multiply or subtract, you get those subtract to give you 79, which is not 1. But now we have to check the opposite combination. So previously we did 5 and 1 and then 7 and 12. So now we're going to do 5 and 12 and 7 and this underlined 1 here. The underlined meaning came from this pair right here. So if we do 5 times 12, you get 60, and 7 times 1, you get 7, and so one subtracts from the other to give you 53, specifically not that middle term of 1. Okay, so what's left? Well, now we're going to do 5 times 2, and we will do 7 times 6. So we do 5 times 2 is 10, and 7 times 6 is 42. Subtract one from the other, 10 and 42, you get 32, which is not our number of 1. But we also have to check the opposite combination. So in this last example here, we did 5 and 2. Now I'm going to do 5 and 6, which is 30. And then we will do 7 and 2, which is 14. Those subtract to, let's see here, 42 minus 30 subtracts to 12. Okay? And we keep going. Let's do the next one. We'll do 5 times what? Well, what's left? We'll do 5 times 3, which is 15, and 7 times 4, which is 28, but those do not subtract. I'm not even going to check it. Those do not subtract to be 1. I can't subtract one from the other to get 1, but let's check the final combination. When we do 5 times 4, we get 20, and when we do 7 times 3, we get 21. So 5 times 4 is 20, 7 times 3 is 21, so that indeed subtracts to equal 1, which is what we wanted to do because that's the sign of that middle term up to absolute value. Okay, so now we're ready to factor it. Now that we've identified this as our pair, we're ready to do the factoring. So we've got 35x squared minus x minus 12. That's equal to, there's our two binomials, and we said that we're going to have 5x and 7x because we wanted the 5 and the 7. That's how we got that particular pair. Notice that when I FOIL out my firsts, I do get 35x squared like I hoped I would. And then we need to plug in the 4 and the 3. Well, when we do my outers and inners, for my outers, I want to do 5 times 4. So we're going to have 5x, and then opposite the 5x, I'm going to put the 4. And when I do my inners, I'm going to multiply my 7x times 3. So opposite the 7x, or another way, in the only spot remaining, I'm going to put the 3. Okay. The next thing to do is to determine the signs. Well, we already said that because this sign was negative, we're looking for these two signs to be opposite so that one subtracts from the other to give me the middle term. So we already knew, don't write this down just yet, folks, we're going to have to change it, that this is either plus and minus, or minus and then plus. So we knew that these two signs would be different because the trailing coefficient had a negative sign. So let's see if we can figure out what they are. My hint from last time was you look at the bigger product. What product is larger? 5x times 4 or 3 times 7x? Well, 5x times 4 is 20x and 3 times 7x is 21x. Which one of those is larger? This one. And so I want to make sure that the sign on my inner terms matches the sign of that middle term. So my 3 times 7x, I want to be minus 21x. So I make this the minus sign and then this the plus. What you should always do is check your answer after the fact. So please pause the video and check your answer by foiling this out. Okay, so we've checked that answer. And you did see that that worked out. I've done the same thing here. By the way, folks, some of you might say, Charles, that took you almost 10 minutes to get through. That was a long time, and yes, I was explaining as I went, but that was a long time. But even if you know other methods, some of you may know a method called the AC method or factor by grouping. You may know some other methods for factoring. This particular factoring problem, I challenge you to use your factoring method and see how that works out. I think that you'll find that no matter what method you take for this problem, it is kind of a lengthy problem. That's my word of encouragement for learning this particular method. Okay, let's keep going. Here we have a very similar trinomial. Notice that we have the same leading coefficient, 35x, and then it's the quadratic term is 35x squared. The constant term is still 12. So notice these pairs are the same as above. The only thing I did here was I removed a lot of the space so we'd have more room to work with. Okay. Likewise, my trailing coefficient is again 12, and so there are all those ordered pairs. And then what I've listed out is all possible combinations. Okay. Now in this case, when we look at the trailing coefficient, this is a positive sign. So we're looking to make sure that my outers and inners add together. So whenever I'm checking these ordered pairs, I'm going to start with this 1 times this 1 and this 35 times this 12. I'm going to check to see whether they add to give me the middle coefficient. Oops, folks, we're missing an x here. I'll include that here in just a second. It'll be there in your notes. So we're checking to make sure that these combine together to give you minus 76x. So we want them to add in the absolute value sense to get to 76. Well, when I do the first pairing, 1 and 1 and 35 times 12, that's what I'm saying, folks, is we're not even going to check that. There's no way that when I add together those two terms that I'm going to arrive at 76. Okay? But then we have to check the other combination. So we do 1 times 12. So this 1 times this 12, and then this 35 times this 1. But when you add those together, you get that they add together to give you 47, not 76. Okay. So that was checking this pair with this pair. Now we'll check this pair with this pair. And when we do that, we'll do 1 times 2 and 35 times 6. Those add to 212, which is not equal 76. So we're not getting any closer to what we want. We keep going, and I'm going to leave you to fill these in. So fill in the word adds to for each one of these, and I want you to fill in all the missing multiples that I've skipped there, and then I'll let you decide what are the pairs that we want. So pause the video and finish filling these out. So folks, one of the things I'll look for when I grade this is, did you fill this all out? But you should have found it was actually this combination right here, the very next one that worked. Because when you do 1 times 6, you get 6. And when you do 35 times 2, you get 70. And those do indeed add to 76, which is exactly what we wanted. Okay? So now we're ready to go factor this. We've got 35x squared minus 76. Remember, I'm missing that x there. Minus 76x plus 12, and so we're going to set up our parentheses. Okay, so we knew this was going to be something x plus something and something x plus something. That's just how we factor trinomials when they come out to give me quadratics like so. And we knew we were going to use either 1 and 35 here or 5 and 7 there because we need to get my first terms to be 35x squared. In this case, we figured out that we wanted 1 and 35. So I'm going to write 1x. If you just want to leave that as x, that's fine. That's perfectly fine. And then there I get 35x. Notice that when I FOIL this out, I first do indeed give me the 35x squared. Then we said that we wanted to multiply for my outers. We want to do 1x times 6. So I'm going to put a 6 over here. That, when I do my outers, gives me 6x. Then when I do my inners, we will do 35x times 2. So opposite the 35 for my outer or for my inners, or in the only spot left, I'm going to put the number 2 there. The next thing is to decide the signs. Notice that since my trailing coefficient here was positive, we knew that these were, don't write this down, folks, that these were either going to be both positive or both negative. because if they're both positive, then when I multiply positive 2 times positive 6, I get the positive 12. Or if they're both negative, when I do minus 2 times minus 6, that also gives me positive 12. Well, which one is it? Now I look at this middle term here. The middle term needs to come out to be negative 76x, so that tells me that I'm going to want these to both be negative. So let's put that in the same color. Okay. Again, you really aren't going to understand how factoring works unless you're always checking your work, which you ought to do anyway. Okay, whew, that was rough, folks. I'm going to go ahead and leave you to work a couple of problems here. Okay. What I'd like you to do in number 25 is I ask you to write out all the factored pairs of the leading and trailing coefficients for this expression here. Please do not try to factor this trinomial. It would take you a long time to do so. It's much too factor rich for us to want to try. Okay. The next thing I'm going to do is in the next two problems I'm going to have you ask the question, are we looking whether they add or subtract to give me that middle coefficient? What are we looking for? Do the products add or do I subtract one from the other? And you're going to do that for each of these two problems. When we pick up in the next video, I'll work number 8 with you and we will keep going. See you soon.